Hi, I'm Brian Walker with Copper Mountain Technologies. Today I want to demonstrate our third order intercept plugin that operates with our VNA. It'll measure output IP3 over a range of frequencies and chart the results, or it can give it to you in tabular results and you can save those. So let's see how this operates. First, you see on the screen we have an introduction that gives you the theory of the third order intercept. The third order intercept is a point where theoretically the third order output intermodulation products are of equal amplitude to the two tones that we'll be generating. Let's look at what we have. We have our C1420 vector network analyzer. We're going to use port 1 and port 3 as our output stimulus to drive the amplifier. We have a combiner here to combine those two tones. We'll run those two tones through this amplifier, this high frequency amplifier from 5 to 18 gigahertz. And then we'll look at the intermodulation products on port 2 of the analyzer. Now it's important for this that we know our absolute signal levels, so we're going to have to do power calibration using this power meter. So let's go ahead and step through this. Oh, there's a power supply up here to drive our amplifier, which is at the moment switched off. So on the next screen, we set up our sweep. We're going to go from 5 gigahertz to 18 gigahertz. We're going to go in 20 steps because we want this to run fairly fast. We could have lots of steps if we wanted a very detailed plot. The tone offset will be 100 kilohertz. And for display purposes, we'll be showing 400 points. And the IF bandwidth is 1 kilohertz, and the amplifier gain is approximately 15 dB. This is important to set the stimulus level appropriately to measure the intermodulation products. So we'll take the next step, and it asks us to attach the power combiner. As you can see, that's already been done. And now we would normally calibrate the stimulus power from ports 1 and 3. This has already been done, but I can show how that would be done. I would simply take this power meter, and I would attach it directly to the combiner, and I would hit the next button, and it would run through all of the frequencies and measure the power levels. And that would correct the stimulus levels on ports 1 and ports 3. The next thing to do would be to calibrate the receiver. This has already been done as well, and because port 1 and 3 have calibrated output levels, port 2 receiver can then be calibrated simply by attaching directly to the combiner and running through the receiver calibration process. We should attach our device under test. So let's do that. And we'll do that with the power turned off. The input will see the signals from ports 1 and 3. I should mention that our 4-port VNAs have the capability of generating separate signals on ports 1 and 2 and 3 and 4. So we're taking advantage of that to generate the second tone from port 3. So now the DUT's connected and I can turn on the power. This is a 6-volt amplifier. And if we go to the next screen, now we can see traditional display of the output IP3, where we see our two tones that we're generating, and we see the two intermodulation products. So we're ready to actually start the measurement. It's important to note that this screen here is for our benefit. The VNA actually steps to each of these frequencies separately in zero span mode at 10 hertz in order to get a very good low noise measurement of each amplitude. So when the VNA is actually making these measurements over frequency, you won't see this display happening at each point. This is just for our benefit to show that everything is working properly. So we're ready to start. We'll go ahead and do that. So now we're going to see each IM point. Here's the VNA screen, by the way. As I said, it's not terribly interesting because it's making these measurements in zero span. But the output IP3 is clearly displayed on the screen. So we're finished. From 5 gigahertz to 18 gigahertz, we see the output IP3 of this amplifier. This is our graph. We can see the tabular data here on the right. I can also look at this as a table and I can verify the signal levels to make sure that everything was done properly. Then I am able to save results. I can export this table either as a PDF or a CSV file. And on the graph, I can go back and I can export that as a PNG or a PDF. And I can save that and then share it. So this is a very easy to use program. It takes the measurements very quickly, and you can get a measurement of the output IP3 of your amplifier.